And in your career and in the culture of conservation, we're going to hear a lot about using a systems approach to conservation with respect to cropland, a systems approach, and that's because the different practices can fit together on operations differently depending on the management style of the producer, the landscape, the soil types, the equipment available. And so I want to give you an overall picture of what a system approach looks like to conservation of cropland conservation. Let me see. There we go. Number one resource concern that we have in cropland is soil erosion by water erosion, and the reason is we disturb large fields, millions of pounds of soil. Some of that soil gets loose and causes pollution and degrades the soil resource base. So I want to begin with an introduction on how soil erosion with water happens. Soil particles become detached from the soil surface when raindrops hit it. Okay, so this is the number one initiator of soil erosion. These particles can be transported, and sometimes they are deposited nearby where they're detached from, but they will also begin to leave the local area and go a distance, being transported by stormwater. And the stormwater runoff carries, and as that runoff with the soil particles in it covers the soil, it will remove more, the velocity and the shear tensions will remove more sediment particles from the soil and carry them over a long distance. And once this sediment is detached, these particles can travel a long distance, and they won't be deposited until they reach a body of water or until the overland flow velocity decreases, and that's usually caused by a change in the elevation of the slope that the runoff is following. So what we're going to look at here for the next 20 minutes or so are practices that address this detachment and the transport of soil particles, and look at how our conservation practices can be used to reduce those problems. But number one primary goal in cropland conservation is to minimize the detachment of the soil particle or sediment. And this is a photograph. This was made by the Navy probably about 60 years ago now, using high-speed film of showing the impact of a raindrop on the soil surface and what happens in a close-up and personal view. And as you see that there's at this small at this miniature level, we can see quite a bit of activity going on. We can see that there are particles suspended in this explosion, of material of water and sediment that is being tossed up and settling back down into the surface of the soil or the runoff as it is here. And this is what causes, this is the number one cause of erosion. If we can stop this from happening, if we can protect the surface of the soil from the raindrops, we are going to have go a long way toward reducing the erosion on that field. So we're going to introduce a term called soil armor here, and that's for the idea is something that I got from the NRCS agronomy guide. The greatest deterrent to soil erosion by water is a vegetative cover, living or dead, on the surface of the soil. So live plants, a canopy, or crop residues, plant residues on the surface of the soil is the greatest deterrent to water erosion. Okay. Cover and culture practice that influence both the detachment and the soil particles and their transport. So we can affect the amount of soil detached and the particle movement by selecting practices that fit together in our conservation system. Growing plants and plant residue absorb the energy of raindrops. They decrease the velocity of the water, runoff water, and they help create conditions that resist erosions. Cultural practices that affect vegetative cover include crop rotations, cover crops, management of crop residue, and tillage practices. So these are kind of the foundational concepts of how we put our system together. A simple way to look at our system is we want to look first at systems that avoid that raindrop impact of on the surface, that avoid the detachment, practices that protect the soil surface. We want to select practices that can control any sediment that is dispersed from the soil, and so that will trap the sediment close to the point of a detachment and prevent prevent surface water pollution down slope. We'd like to slow down sediment movement, and we'd like to make sure that we have a way of trapping any sediment that becomes that gets away from the field edge and heading towards the stream. We want to trap that, and so we use this acronym ACT, A-C-T, avoid, controlling, and trapping. So this is one way of looking at your soils, at your conservation system on cropland. There'll be some other systems that you become familiar with through your career, but right now this is a very good one to remember. What are the practices that protect the soil surface? Some primary practices that we have: a good crop rotation with a cover crop plan. Okay, these provide a good canopy and lots of roots in the soil to knit the soil together. Okay, also it's important to have a minimal or no-till residue and tillage management system. Okay, so these are practices that avoid the detachment and help to minimize the movement of our soil sediment. Crop rotations. We want diversity in our crop rotations. Okay, we want different kinds of different plants and different combinations of residue on the surface of our soil. And so these could include grasses and legumes, as well as row crops and small grains, which are close sown crops planted with a grain drill in very narrow rows. We have some annual and perennial mixed in there, and we want to have cover crops when appropriate. Okay, we're going to be able to benefits of the crop rotation or improved nutrient utilization, and possibly to reduce external inputs such as nitrogen and increase the soil biology, improving soil health, reduce the impact of insect pests, life cycles, and disease pests, and to spread out the labor and the risk on the farm, so that the farmer doesn't have eggs all in one basket. So diversity in a crop rotation is number one. I'm going to spend a little time here with cover cropping. Cover cropping provides multiple benefits. It provides that soil armor in the time of the year when the main crop is not growing on the soil. There's a great opportunity to absorb sunlight during the growing season while there's still plenty of temperature and moisture around to support plant growth. And so we want to get a cover crop planted in. It feeds the soil biology. And as you move through your orientation and your initial training here, you're going to learn more about soil health and the importance of soil biology. So the more living plants that you have growing in the soil over time, the greater the amount of biology, the greater the nutrient cycling, and benefits that come from having healthy soil. Nutrient uptake and efficiency. Cover crops will hold your manure nutrients, and they'll hold nutrients that become available after the main crop is harvested. Soils have a natural tendency to generate leachable nitrate, nitrogen, after harvest is conducted on in field crops, and that nitrate, nitrogen has the ability to leach down into our groundwater. Well, if we have a cover crop growing, we don't have that. We have a way of taking up that nitrate into the cover crop to use it for the following crop, one of the following crops. So we have the ability to reduce purchased nutrients, and we can increase infiltration, reduce runoff and soil erosion with cover crop, and it can provide us with a forage production. If we're in a tight spot, we can use that cover crop as an emergency crop for feeding our critters. When it's planted early, when we replace residue, okay, so when we harvest soybeans or we harvest corn silage, there's very little residue left on the surface of the soil, and it's very important to plant that cover crop in an early manner so that we get that soil protected. In the fall, it's more important to plant the cover crop before spreading manure than it is to spread manure before planting cover crop. Plant the cover crop first and let it come up and spread the manure over top of that later. We find that we get the best results environmentally and agronomically when we follow that way. Other benefits of cover cropping is that it increases aggregate stability, and you'll learn more about the importance of aggregate stability as we learn more about agronomy in our career. But it's a function of increased soil organic matter, and it reduces our erosivity of the soil as we have stronger and more stable aggregates. Cover crops can reduce weeds. It keeps something growing year round, mimicking nature as nature keeps things growing year round, and increases biomass. There's a term called planting green into cover crops that is being experimented with across Pennsylvania and the United States by innovative farmers. And what they're doing is they're allowing their cover crop to keep growing, and they're planting their main crop into the growing cover crop into the spring. Okay, and so that there's like a mat or a mulch of this cover crop residue, okay, that they plant into that provides a buffering, a temperature moderating, a transpiration reducing mulch that will improve the performance of the main crop. This is a new and experimental practice in the cover crop field. So planting green. Interplanting is when we plant covers into forages or into a main crop. We have interseeding where we can plant the cover crop into the forage to beef up the amount of biomass that will be available the following spring, or we can plant interseed into a main crop, interseed a cover crop into a main crop, and so that when the main crop is removed, the cover crop is already established under that canopy. Again, these are innovative practices that we're looking to innovative farmers and Penn State researchers to help us understand where, when, and where these practices are going to be recommended. There's a number of ways of establishing cover crops. Probably the gold standard is using a drill planter, a grain drill seeder, and plant that cover crop immediately following the main crop harvest. Sometimes time can be a bind, and so broadcasting the seed with like a spinner spreader following crop harvest, and manure, maybe before manure application, after manure application, will get the seed out there. It's not as good a practice as drilling, because drilling places the seed in soil contact, so that the seeds can germinate, and it plants them at a depth that they're going to thrive at. Whereas broadcasting, it's kind of hit and miss. The seed to soil contact is iffy. A lot depends on the weather following the broadcasting of the seed. Then there's interseeding. Interseeding is planting the cover crop into a growing crop. So interseeding is an example of that would be when a interseeding drill is run through corn in mid-June, and the corn is about 8 inches to 10 inches tall. And between the rows, this drill will plant a cover crop, which will germinate and then be ready to grow when the corn is taken off. So this can happen with corn. It can happen with soybeans. We don't have strong recommendations from Penn State, but we have a lot of research going on in Pennsylvania to understand where and when this works. Broadcasting into nearly standing corn. So for instance, in aerial seeding, an airplane seeding would be an example of broadcasting seed into a standing crop that's nearly mature. Not recommended in Pennsylvania, very hit and miss. Whether that works, we have a number of things working against us for aerial seeding, such as the small field sizes, the inconsistency between airports and locations that have different types of fuel and runways that the equipment needs to operate on. So broadcasting seed into a standing crop that's nearly mature is not highly recommended in Pennsylvania. It could also be, you can also put the cover crop seed into the liquid manure and spread that at the same time. That's another practice that people did. But it's important to get the cover crop planted in time, because as you know, the days get shorter and nights get longer, temperatures become cooler, and so we want to get those cover crops planted as early as possible before we lose our growing season. And it's important to plan the cover crop as part of the rotation. Plan it that it's not an afterthought to plant a cover crop. A cover crop should become integral to the crop management plan that the farmer adopts. Residue management. This is what comes out behind the harvesting equipment and what's left behind in the field. It's important that those residues are spread evenly at harvest, okay? Because they're going to reduce the detachment of soil particles by covering the soil. They're number one soil armor feature. Increase infiltration by protecting the surface of the soil. Conserve the soil as a mulch and provide food for microorganisms, and that includes our earthworms that need to feed off the surface of the soil. So we want to get the crop residues evenly spread so we don't have striping in the field caused by high and low levels of residue across the field because it wasn't spread out the full width of our planting equipment. A little bit about tillage. Common tillage systems we have and that we follow are primary tillage, reduced tillage, and no tillage. And so the primary tillage is the probably the most ancient and had been the dominant system until recent decades. This is using a plow, a very heavy disc, an aggressive chisel to break up the soil, to flip it over, to turn it into large clods. And when we practice primary tillage, we're going to need to use a secondary tillage pass, which is a disc or a field cultivator, some type of tool that's going to break up those large clods and prepare the seed bed for establishment. So once we do that primary tillage, we're eliminating a lot of the residue that's on the surface and usually end up with a very clean seed bed. Okay, and while that seed bed may be attractive because it's nice and clean and we have that soil smell in the air, it's also very vulnerable to raindrop impacts and erosion. Reduced tillage systems avoid using the plow and the very heavy disc, but we'll use a chisel or a disc followed by a field cultivator to smooth out the soil. This system came into fashion in the 1970s as energy prices went up. The cost of primary tillage became prohibitive for many operations, and they also realized that this type of tillage, also called conservation tillage, could be practiced and it would leave more residue on the surface of the soil. And of course, what we know about residue, it's number one soil armor. There are also reduced tillage can be as simple as what they call vertical tillage tools, turbo tills and Salfords that only have straight coulter blades, okay, as opposed to a concave blade of a disc. And they do soil disturbance, but they don't go as deep and they're not as aggressive and they don't flip the soil. And so it takes a better, stronger no-till planter or grain drill to plant into these reduced tillage systems. No-till planting is by definition, no-till planting and the no-till standard is an annual practice. And so that means that we don't till the soil from the time of the harvest of the previous crop until the harvest of the main crop that we're following with that practice. When it's rotated with tillage, say we have 2 years of no-till planting followed by 2 years of reduced till practice or primary tillage practices, okay, we're going to lose the benefits that we get from our no-till operation. There are a lot of benefits associated with no-till, both for the soil and for the farmer. For the farmer, they can reduce their labor and fuel expenditures on preparing that field by about 65%, and can reduce in no-till. It can reduce erosion when practiced continuously very significantly. Okay, so but no tillage operations, no full width tillage, no turbo tills, no discs, no harrows may be used when practicing no-till, and it can help the farmer to get the crops planted in a timely fashion. Now, what if we practice a continuous no-till system over a long period of time, and we use cover crops, and we use crop rotations with diversity, we can develop a very nice soil health system. And you'll learn more about soil health systems. This will become the dominant model during your career. There's a movement now to adopt soil health systems. It's a applied science that is now becoming understood and we can nearly eliminate soil erosion and runoff while reducing crop production costs. And so that is a continuous no-till system year after year over a long period of time. Now, there's a transition period between the time that one would stop tilling and one would begin a continuous no-till system, that if one goes kind of cold turkey from practicing a tillage system, a reduced tillage or a primary tillage system, into a no-till system where there can be a lag, a yield drag, okay? And so it's important that it's recognized that this transition should take place over some time, and use practices such as cover crops, diverse crop rotations, and thoughtful management, okay, to transition from a tillage system into a no-till system. There's a publication that is available at your offices called Soil Health in the Field and Forage Crop Production. Soil Health in Field and Forage Crop Production, that's written by Dr. Schuart Diker, former state agronomist Joel Myers, and Lisa Blazier of the Soil Health Coalition in Pennsylvania. I encourage you to read that. It's written in farmer language, and so to take some of those along with you when you visit farmers, when the conversation turns to no-till and soil health, to present a copy of that book to the farmers that you're working with. So once we've protected the soil with soil armor, with diversity, with minimal tillage or no tillage, okay, we're still going to have some sediment detachment and movement downslope. It's something that's very difficult to avoid because of the nature of our storms and our topography and our soils. So we have other practices that will help increase infiltration of stormwater, that decrease runoff, and thereby decreasing the downslope movement of sediment. And these practices are soil contour farming, strip cropping, and contour buffers. Contour farming is most effective on fields with a hill slope of 8% or less. Its effectiveness is based on row grade, ridge height, and residue cover in the fields on the field slope, typically used in conjunction with terraces and reduced tillage systems. Agronomic practices such as cover cropping and crop residue management are also important in that. So what we're doing here is we are planting on the contour, okay? That is perpendicular to up and down the hill. So rather than farming up and down the hill or willy-nilly, farmers are very consciously operating all of their farm field operations on the contour, going around the slope rather than up and down the slope, okay? When they do farm that way, it creates ridges behind the farming equipment, and those ridges are very good at capturing runoff as it proceeds down the hill and controls the sediment flow, and we get some deposition so that we have a better quality. Strip cropping and contour buffers, these are practices that provide strips that trap sediment produced from upslope cropland areas when we have runoff. Okay, so in strip cropping and in let's talk about contour buffer strips first. If we have a hillside and the producer is wanting to have all corn on that hill slope, but it's a severe slope that is going to have a lot of erosion and a lot of sheet flow over the surface of the soil, okay, the farmer can place a grass buffer strip, okay, 10 or 15 feet, 20 feet wide on the contour going around the slope, okay, and that will slow down the velocity of runoff water and cause some soil to deposit there into that vegetative buffer on its way down the hill. Okay, strip cropping is the alternate planting of crops in strips, where we alternate between a strip that is in a sediment producing condition with a strip that is more vegetative, close sown, that it will actually capture residue, similar to the way a contour buffer strip captures sediment. That the water will hit that more vegetated strip, and the velocity of the water will slow, and that causes the sediment that is in suspension in that runoff water to deposit at the upper edge of that strip. And so you'll see strips in an old system where the upper edge of the strip is a higher elevation than the lower edge of the strip immediately before it. And that's due to the deposition of soil sediment over time. The popularity of these practices varies across the state. So some areas that you work in Pennsylvania may be open to practicing these contour buffer strips and strip cropping, while other areas there may be community resistance to practicing those simply because it's not the common practice in the area. Remember that when our strip cropping and our contour buffer strips slow down, so this is the movement of sediment by trapping it on a strip by strip basis. So it doesn't keep the soil in place as those practices that have soil armor, that feature soil armor, but it does slow down the movement of the soil once its erosion process has begun. Strip crops can help reduce the presence of gullies where the rainfall factors, the intensity of the rainfall is lower. So in Pennsylvania. So up in Northwest Pennsylvania, we have lighter rainfall. It's possible to adopt strip cropping and buffer strips to help reduce the occurrence of gullies. Practices that slow down the soil movement and trap sediment are diversions and cropland terraces, which I know you've become somewhat familiar with in some of the other boot camp trainings. Okay, these are I don't want to call them ditches. They are engineered practices that sculpt the soil surface so as to collect water on its way down the hill, runoff on its way down the slope, and will either divert it away from moving further downslope to a stable outlet, or provide a basin in the terrace so that the runoff and overland flow can absorb into the soil. We need to have a stable waterway, a stable outlet, pardon me, which often is a grass waterway to serve as an outlet for these diversions and terraces. And grass waterways, level lip spreaders, these can also help control gullies and concentrated flow erosion. Buffers and filter strips are finally let me see if we'll go into grass waterways here. No. Grass waterways, vegetative, parabolic, that means flat bottom channels that serve several purposes. Okay, so grass waterways are outlets for diversions and terraces. They can also serve as vegetative channels to carry out concentrated surface water flow. Okay, so if there are places in the landscape that naturally develop into gullies because of their position in the landscape and the topography of the fields, often that is a location where a grass waterway should be placed to avoid the erosion caused by concentrated flow, creating gullies. Okay. Waterways may be harvested for forage production. So a benefit or kind of a trade-off is while the farm field where the waterway is located might lose some production from its main crop, the waterway itself can serve as a source of forage when harvested for forage production. Terraces and diversions. Diversions are vegetative cross-slope channels used on steeper slopes to break the slope length and safely carry concentrated flow to a stabilized outlet. Whereas cropland terraces are cropped across the slope channels used on flatter, less than 8% slopes to break the slope and carry to a concentrated outlet. Okay. So producers may favor these over waterways as they can be farmed. Cropland terraces may be farmed along with the rest of the field in the main crop. Channels and slopes of these practices should be shaped to facilitate forage production if desired for diversions and facilitate cropping in the case of cropland terraces. They use these to protect critical areas such as farmsteads and other areas where surface runoff can create larger resource concerns. So say they break the slope, they actually divert the water from its downhill movement to a lateral movement and removes it from the field, decreasing erosion. Then finally, we have buffers and filter strips. These are our vegetative practices immediately adjacent to streams and water bodies. They're our last line of defense to protect water quality from the sediment produced by erosion. They shouldn't be thought of as a substitute for practicing the upland conservation practices that we just reviewed. Otherwise, those slopes will create so much sediment if we have erosion upslope that they'll just overwhelm these buffers. And so it's important that cropland but be treated to T, less than several tons of soil loss per acre per year, to avoid overloading the buffers and filter strips and allow them to function properly. Now, it's also important that we maintain sheet flow as opposed to concentrated flow when the water entering buffers, filter strips, even strip cropping and contour buffer strips. It needs to enter that buffer area in sheet flow. And you'll learn more about sheet flow and concentrated flow in future trainings. Okay, but we need to maintain sheet flow entering the buffer or the strip. And so those are some of the practices we use to avoid, control, and trap sediment detachment and transport and deposition. And so I open that up to some questions. And Tim, is there anything in the chat?
Yes, there is, Mark. Can you explain the difference between row grade and slope?
Yes. Okay, slope is the up and down the hill elevation change. Okay, so if we were to stand on a hill and to drop a bowling ball and it would roll down the slope, that is our slope of the hillside. And we make some measurements of that when we're estimating our slope for erosion calculations. Okay, that's slope up and down the hill. Now, when we practice contour farming, we are going around the slope rather than up and down the hill. When we are going around the slope in a near level, okay, right on if we were perfectly on the contour when we were farming, our tractor, our farming equipment would be perfectly level going around the slope. Okay, that would be a row grade of 0%. So while the up and down the hill slope has a percent, if we are perfectly on the contour farming, we have 0% row grade. Now, our row grades tend not to be perfect because we have mixed topography, rolling topography. So our row grades sometimes deviate up plus or minus up a percentage or two. We measure that row grade using the clinometer. That's the same clinometer that we use to measure the steepness of the hill. But we would like the row grade to be as close to 0 as possible, so that when we do that's where we do our farming around the slope, and the farming equipment is level or nearly level in elevation.
Thanks, Mark. And the next question, what can be done when one of the slowing features, like a strip and strip cropping or terrace, fills up with sediment?
Well, we need to do maintenance maintenance to that practice. Okay, so they'll basically go at each of these practices that we have a lifespan, and those lifespans generally 10 to 15 years is what we plan them to. And so after that period of time, it's necessary to go in with a blade and reshape the practice to renew it back to its original specifications.
Very good. And that's all of the questions. Now you have a quiz question. Can I present that now?
Yeah, sure. Go right ahead.
Okay, I'm going to put the link in the chat and I'll share my screen. Okay, everybody should be able to see that now. And the question is, according to the NRCS Agronomy Manual, the greatest detriment to soil erosion by water is, or deterrent to soil erosion by water is, sorry, that's a key word there.
That's a fill in the blank question.
And we're getting some good responses. I'm going to let a couple more people answer before I go into the details there. Okay, if I click on this, looks like we've got vegetation, soil armoring, soil cover, ground cover, runoff soil cover.
Okay, good answers.
Yes.
Yep, good answers. It's soil armor, vegetative cover, both living and dead, crop residue cover, living crop canopy. Those are all that gets us in the ballpark. So soil armor and practices and managements that will increase that and maintain that are those greatest deterrents. Living and dead vegetative cover on the soil surface. Good.
Excellent. Very good. Thank you for all that participated. We appreciate that. And big thanks to Mark Goodson, our state agronomist. So Mark, that concludes all the questions. And do you have anything else to say, or are we good?
We're good for right now. Thank you.
Very good. Well, we're going to move on to our next presentation then. And our next presenter is Jen Harold. Jen Harold's an engineer out in Western Pennsylvania. She works out of the Somerset Technical Office. And Jen and her family have a beef farm operation as well. So a little side note. And Jen does a great job out west. So Jen, with that, it is all yours.
Okay. Can you guys hear me?
Yeah, I hear you well.
Okay, let me just figure out how to show my screen.
Sure. There's a box with an arrow pointing up next to kind of the mute button. And if you click on that, you'll be presented with a couple options, probably the lower part of your screen. You can choose either your presentation or your screen.
Alrighty. Okay, can you see my...
No,
not yet.
Nothing yet, no.
Okay.
I don't think I have your presentation, Jen, but if you want to email it to me, I can present it for you too, if there's issues with your computer on your end.
Okay. Oh. Now do you see it?
Yeah, it looks good.
Okay. All right. Okay, yeah, like Tim said, I work out of Somerset. I just realized I've had 25 of years of working as an engineer, which is hard to believe. I started out at Mercer County Conservation District and took the first round of nutrient management exams. And then I moved on to a civil engineering consulting firm. I worked as the Bay engineer out of the Somerset district. And then the last 18 years, I've worked with NRCS in Somerset as ag engineer. So it's been interesting. So one thing to realize today, it was good seeing Mark's presentation. He kind of talked about some of the engineering things that we may do, diversions, terraces, waterways. So Justin and I will be chatting about engineering practices here the last day of your boot camp. So yes, we have a certified organic farm. This is our farm here. We have about 20 some cow-calf pairs, and we're about halfway done with calving this season. And we keep growing. I think JB farms about 300 acres. Our two children, Tyler's a senior in high school and Allison is a sophomore. They help a lot on the farm. With COVID last year, something that was kind of interesting was Allison and Tyler were remote learning, which they didn't really do a whole lot, but Alice became our herdsman. And it's been amazing how she's tamed all of the cattle. Before, some of the cows, if you try to help their calf and move them into the barn, they about try to kill you or throw you over the fence. But with her calming them all and taming them, all the cows are very friendly, and all the yearlings and 2-year-old cattle are as well. So that's been pretty neat to see. And I don't know if she's going to end up being a veterinarian or what, but that was kind of a neat thing. Okay, so what I'm going to chat about today is basically working with the Field Office Tech Guide standards specifications. So my presentation kind of leads towards waterways, but this just giving you the process of how do we design them, what's in the design package, and certifying them. So let's see here. Okay, so in planning, I know with EQIP, I'm not sure how many of you are NRCSers and dealing with contracting, but we have to worry about cultural resources. And right now we're contracting, and we really should know at that point if we have a cultural resource and if we can work around it or what we have to do. So that's in the planning phase that we would have to consider that. Also in the pre-design phase, we would have to do a PA1 call. That may change the location of a structure, depending if there's a gas line, something like that. Some utilities, overhead utilities are a concern as well. So the NRCS Field Office Tech Guide is the foundation of all conservation practices. It's available on ePhotog. National standards are used to update and make state specific to PA. So I see a lot of times the state office is working on updating and sending them out for comments, so to make sure it's more specific to our state. These standards and specifications are science-based, and they're proven and they work. It's a minimum requirement, and we are required to follow them. The job approval system, where the state engineer is basically overseeing all of the engineering work, we have to make sure we follow our our job approval and meet the standards and specifications, and work under Pete at this point. There's liability issues if we don't follow the standards and specifications. So I'm not sure if you guys this week had gone through and how to find ePhotog, but here's a couple of screenshots on how we go about it. You'll have to enter the state, and then this has been recently updated. It used to, okay, so you look under section 4 of the tech guide, conservation practices, standards and support documentation. And there's a couple of things that have been changed in the description. So the CPS stands for Conservation Practice Standard. So that's the basis of the design, what we follow, how we design it. And then the PS is the practice specification. So that was kind of hard for me to adjust to because it used to say standard or specification. So CPS and PS are what I would go to first if I was going to go out to a farm and I wasn't familiar with things that we kind of knew what the landowner wanted to do. And then let's see what else here. So these are the items that you'd find here in ePhotog. Not all of our engineering practices have a job sheet, but the job sheet kind of gives a short summary of what the practice is. It gives you the definition, where do you use it, and here's a nice little diagram of showing a trapezoidal with a flat bottom, or the parabolic, which is a gradual curve to the bottom of the waterway or diversion. This has, general vegetation requirements, operation and maintenance. So this is just a good thing if you are unfamiliar with the practice, go look at ePhotog, see what they have available for you to learn more about the practice. So like I said, if I'm going to do a design, I always pull out the practice standard, kind of go through here. I highlighted a few things. The practice is Mark talked about waterways a good bit. So I won't go on to exactly what he, repeat what he said, but from here I would see like the capacity, you're looking at a 10-year, 24-hour duration typically. If you're going to protect a waterway, or a waterway is going to protect a structure, then we'd have to size it for the 25-year storm. But this gives some good guidance on slopes, if the slope's less than 1% and, out of bank flow is okay. The stability portion, it refers to Engineering Field Handbook, Chapter 7. So this is just a good guide, get some guidance on general, avoid what slopes, this 0.7 to 1.3, the width, less than 100 feet, things like that. So I'd run through, highlight the information that seems pertinent, so you can talk freely with a farmer. You know what you need to obtain for design. And the other thing is the practice specification. So this is more so whenever you're doing the design package. A lot of times we include this and then the additional conditions, which would be written to be site specific, say the width, the length, the erosion control blanket, things like that would be included, in addition to putting this practice specification in the design package. And another great tool is, before I'm going to go survey and design, you pull out the design and check data for your practice that you're going to design. It gives you really good information, what you need to survey, what you need to document as a design record, the construction record, as-built, what you need, the slope, the width, the depth, the seeding, you know, which seed was spread, the erosion control matting, what was used, stuff like that. So just a really good sheet to print off, and I would just check off as you do each of these items. So here's an old example back when we did it on paper, but this is just a waterway. The outlet is always station 0. I think there's maybe a culvert or something that is collected and conveyed through this waterway would be the station at the furthest most point, like station 15 plus 50. So they've got really good information with each reach. A reach is a section of the waterway that has the same slope. So each reach is going to have a different depth and width and maybe a different lining. So for your design, as you would refer to your design and check data, you need some cross sections for each reach, and then you show the dotted line as the final grade, the line dash is the existing grade to show what's being removed. And for this one, there was a basin with a riser, and it gives the specifications on the pipe riser and pipe holes and slots and so forth. The other thing is providing good details. What kind of erosion control blanket do you need? Or if it's a faster, more aggressive flow, you'll need a permanent lining. So we would provide what the lining would be and how wide it needs to be within the waterway. Sometimes we have a rock lined waterway. So depending on what you figure out when you're designing, you get your cue, which you guys talked about hydrology the other day. Get your cue, do some survey, do a profile, some cross sections, and run through EFT to get your waterway width and depth. And then I mentioned, in addition to the construction spec in the design, I would put the additional conditions, which, like I said, is site specific, where, okay, we have 3 waterways here. Here's the general information for the project, the erosion control blankets included, things like that. The one thing is, if you're going to oversee construction and be the inspector, you would have to work with the landowner or the contractor to get the information on the materials being used to build the waterway. So you would have to ask them, what are they using, make sure it meets our specs in the design. So here's just a couple of photos of planning to implementation. Here you see on the right is a tile that broke, and you can see there's some erosion caused at this location. We start waterways from various things like this culvert on the right, or on the left, dumped into looks like type of a manhole, where we would probably have a little bit of an energy dissipator at the end of the culvert, have a basin, and then outlet it into a waterway. So here's some pictures. On the right is a waterway where they moved the topsoil. They began shaping the waterway with a dozer. Once they got it shaped correctly, the correct shape, slope, depth, then they started placing the erosion control blanket, which you work from the bottom up. And then at the end of that culvert, this low flow water is going to be directed to this basin, which will go into a pipe. You can see the riser, and then it'll go. It'll kind of protect the waterway from the low flow, so your grass can get established. So the water will be conveyed to an outlet from the basin, and if you get a bigger storm, it's going to go over this bank and then down through the waterway. And then as inspection, occurs during, checking the materials, making sure it meets our standards and specifications. Okay, so that was my talk on the standards and specifications. And my next one is get started here. Okay. All right, so soil is a construction material. You've talked about soil as soil health, maybe.
Jen, I don't see your presentation.
Oh, you don't?
Okay. Not yet, no.
Okay.
And while you're doing that, I just wanted to draw out one thing that Jen said and make sure that everyone heard that, when Jen was showing us about the Field Office Tech Guide and ePhotog and talking about the standards and specs, she mentioned that whenever she's designing something, she's going back to those standards. And I just think that is such good advice. And I hope that you all heard that and take that with you when you are out working on different projects. It's so important that we're going back to Photog and those documents and those standards. And Jen, even with all of her years and years of experience, is still doing that. And the standards do change from time to time, but we try to highlight that whenever there are any sort of significant changes. But really good advice, and I wanted to make sure that that was emphasized.
Okay. Can you see my soil presentation?
No, not yet.
No. Okay.
No.
I don't know what I'm doing wrong.
Oh,
let's see here. Now can you?
It's coming. Yeah, we see it. Great.
Okay. All right. Okay. Whoops. Okay. All right. So, like I said, I'm going to talk about soil as a construction material. We build a lot of things with soil. And let me get here. Okay. All right. So on our sites, a lot of times the material, our project sites, either the material's on site or you have to haul it into the project. So I'm not sure if you guys talked about the ribbon soil test. A lot of times we don't get super fancy with lab testing. If we were to build a pond or something like that, we would always just send that into the national office for them to evaluate the soils. But a lot of times to determine our soil texture, we would use the ribbon test. A lot of the stuff we do wouldn't require this hydrometer soil testing like a laboratory test would do to determine the sand, silt, and clay. We use the simple feel method, adding a little water, trying to make a ribbon, see how long you can get it. For compaction, for some of our projects, there's a certain manure storage that requires to make sure that the subbase is meeting the 2,000 pounds per square foot. So they may have a geotechnical engineer come out and evaluate that. But typically we're just using our simple methods. And we always send the work out to a lab if we do need to determine if the soil is suitable or if it could be used for a liner for a pond, the thickness and everything. So the soil characteristics, we usually use this unified soil classification system, which is broken down into gravels, sands, silts, and clays, and organics. So gravels, which we use typically in our engineering practices, would be for an access road, an animal trail, rock riprap for rock line waterway, an outlet, bedding material under a storage for drain fill. It's not really good for compaction or it's definitely permeable, so that it's not a liquid tight material. So sands are good for strength, but can't really be compacted be compacted, and they're very pervious. Silts aren't great for strength, but they can be compacted and are sometimes impervious. So a lot of our fill may be like a compacted fill material. We see some clays rolled in, not good for strength, but very good for compaction, impervious. That's good for a liner for a liquid HDP lined pond as one of the layers. Organics are not good for construction. Those are great for vegetation establishment. We push our topsoils off to the side, save them to top dress, and to get a good stand of green onto the site. So the sands and gravels, like I said, are better for foundation and drainage, and they're more erosion resistant. We talk about riprap and in designing waterways, like a rockline waterway or an outlet. The silts and clays are great for compaction, and like I said, we're using those typically to build a basin or as a liner for a liquid storage. So for the coarse material, it all depends on if it's a coarse material, sand or gravel, if more than 50% is kept onto the sieve when you're processing that. And the fine material, if it's more than 50%, it passes, then it's considered a fine material. So when we're using the Unified Soil Classification System, we use a prefix and a suffix. So GW, SM, ML, CL. So the grants, it's pretty easy to follow. Some of the silt, what is the M, sand, S, gravel, G, clay, organic, peat. So you'll see a combination of the sort. So here's a good summary of, you know, the GW is a well-drained GP. These gravels are well-drained. SM, SC, you know, here's a lot of combinations. If you look in the Web Soil Survey into the Soil Unified Classification System, this information is in there. So whenever we design a roof structure, we have to determine the post footing dimensions. We have to look at the site and determine the soils and size it accordingly. Sometimes we're not really sure, you know, we can see what was on the map, but there may be a surprise here and there. So, you know, test pits are handy for all of our structures. We look at the soil type, the depth of water, depth of bedrock, and if it's karst. So that would be like for manure storage, we would do test pits to determine and look at those things. And say if you dig down 3 feet and there's rock for a liquid storage, you're going to get into some major cost if the rock isn't rippable and you have to blast it or something like that. So it's kind of good to do that as soon as we can to determine if there's going to be extra cost involved for rock removal. There is a updated soil investigation log right here where you have your test pit. You would draw a little plan view, and with each layer as you dig and log the material, the depth, if you find water, if there's rock, and you would use your ribbon test to determine what type of material we have for the soil. So here's an interesting site. This was in Blair County a few years back. So you can see this is beautiful karst area. There were, you can see 1, 2, 3, 4, 5 or 6 holes on the right picture in the back there. There were 6 test pits dug. And if you look at them, the soils are also very different just in this small area. So that was quite interesting, and I thought was a good indication of, oh, over the years, you know, soil erosion and just the way the area is with karst and what you may be surprised to find. Here's a good example of digging test pits. This was a planned round storage, and this was very well documented. The test pit location, they measured off of landmarks, so you could know exactly where they were and put that into your survey. Because in a liquid storage design, you need to have to include your soil test pit information. It's good for the planning on knowing if we have to have rock or if there's going to be a lot of water. We need a 6-inch perforated tile around as the foundation drain versus a 4-inch, and plus cost for if there's rock excavation. So they did a really nice job. They had 3 test pits, the logging information here, and with these we're looking for, like I said, water, rock. Is the rock rippable or not? And they took really good pictures of the holes as they were digging. So this was just an excellent example of test pit log. And they even surveyed them in, and I tied that into my design. So using soil as a construction material, you may have like say a wetland where you have an embankment, and you may have a directions on how many passes with different type of material, or if you have a liquid storage that's HDP lined, you would have specs on the thickness of the layer, how is it to be compacted. Even if we have just a manure storage in a karst area, we have to have a 1-foot clay liner underneath the storage. And clearly you have to put that in your design to know what, to give the contractor an idea of what they need to do and what material we need to bring in, or if it's on site. This is an example where it was a embankment that was being repaired for muskrat damage from a easement. So they had a couple options. You have a sheep's foot roller, the lift, 8-inch lift, how many passes. So it's good to give contractors options of what type of equipment, the lift thickness, and how many passes, because they have options, and you're probably going to ask if it's not on there. So it's better to have it in the design, I think, ahead of time. We put this pipe bedding detail in our structures or design packages. This is protecting the pipe as travel. If there's travel over the pipeline, you want to make sure your pipe is bedded below the pipe and around it to the spring line to protect it, because it's going to deflect if there's traffic over it. And with the embedment material, it protects the pipe. So like I said, this is an example where we're drilling holes for a roof structure. Have the inspector out there checking things out, see if there's anything that's surprising. Can they get to the right depth? Was material kind of out of the ordinary? And documenting that. This is a nice little remote controlled sheep's foot roller where they were compacting a manure. There was a manure pipe, a gravity transfer line that led from a reception pit to this new waste storage structure. So they did a really nice job compacting the soil back in just to prevent settling, protect the pipe from crushing, things like that. Here's a sheep's foot roller or a vibratory roller. A lot of times we have to bring in fill. We have to evaluate that material, roll it in, 6-inch lifts, how many passes. Those are the things that you would see in our engineering designs. For a ag waste, they did a really nice job here on the left, benching the cut slope, making it safer for the workers down along the wall, placing forms and doing all their work. There's a plate compactor on the excavator here on the right. just a nice tool to use to backfill against storages. We don't want to have a lot of weight against the wall to crack it or have any issues. So you see this a lot on the site as they compact around a tank. This is I think this is stage one of like a settling, sand settling basin and then they would overflow into a larger pond. So they're using soil on site, and they have a pan on the left moving a lot of soil. So you'll see we don't do a lot of this type of work in this area. A lot of times it gets into complicated permitting, so that goes to a private engineer. But this is definitely soil as a construction material. So that's just a little bit on standards and specs, and then soil as a construction material. That's all I have for now, Tim.
Excellent. Thank you, Jen. And with that, I am going to share your first question, if that's okay.
Okay.
And let me share my screen. All right, hopefully you can see the question. And the questions, and I'll copy the link and put it in the chat. All right, folks, it should be in the chat there for you, but construction is underway for a roof structure. Potholes are being drilled for the post footings. The concrete footings are to be 8-inch pad, 24-inch diameter, plus an additional 12-inch concrete collar with a total of 4-foot depth from the top of the finished concrete. As holes are being drilled, the quality assurance personnel notice that old building materials, lumber, tree roots, broken concrete blocks, and gravel are being brought up as the holes are being drilled. Not typical soil. What should the quality assurance personnel do? And there's several options for you there. And we're starting to get some responses in. And it looks like, Jen, a majority of people are saying to call the engineer of record. What's your thought, Jen?
Yes, that is correct. I didn't really cover that. It's always hard when to make sure you cover everything. But yeah, if you're going to make any changes to the design, you need to talk to the engineer. So yes, that
Excellent.
is correct. Mm-hmm.
Very good. Hey, thank you for participating, everyone. We appreciate that. And with that, we are going to transition into a break before our next presentation. So I'm going to start our 10-minute clock, and we will get back here in about 10 minutes. Go get your coffee and do whatever else you need to do, and we'll be back here in 10 minutes. Thanks a lot. All right, I hope everyone is back from their 10-minute break. We're going to get going again, and our next presentation is from another engineering staff from Western PA, and this is going to be Justin Gribble, who's the area CET up in the Clarion Tech office. So, Justin, at this point, the floor is yours.
All righty, thanks, Tim. Can you hear me okay?
Yeah, I hear you, and your presentation is showing up.
All right, great. As Tim said, I'm the CET up in the Clarion Northwest area. I've been up here for almost 20 years now, believe it or not, but I'm just going to talk briefly about quality assurance plans and a little bit of practices and inspection that was required with our projects. So the first thing that we're looking at, excuse me one second, is the quality assurance plan. It's probably one of the most important parts of every design. Is basically laying out what the inspector needs to inspect on the project, is basically the directions and the rules and responsibilities that need to be followed through to ensure a quality project is built. And what we're looking at here is just the first page of it. It's a fairly detailed quality assurance plan, but you can see the first item we're going to look at would be installing the ENS controls, removing topsoil, and it just lays out the different steps of the construction that we need to check, such as pouring the concrete floor, checking the reinforcing steel, items like that. And it also lays out how often you should be checking for those items. If it's a concrete pour, you need to be on site every day they're pouring concrete. If they're just installing reinforcing steel, stop out a couple of times while they're installing it, and then you want to stop out and inspect that before they place the concrete. But the next part of the quality assurance plan, it just lays out the rules and responsibilities. And the part you really need to pay attention to, we have a lot of trouble with the primary inspector. If they can't be on site, it's their responsibility to line up a backup inspector and to coordinate with that person to ensure that inspection is always being done on the project. But the quality assurance plan also lays out the different items you'd need to do the inspection, whether it be a slump cone, rules, tape measure, compaction testing. All those specific items to be laid out in the quality assurance plan. And it also tells you the specific items to look for within the concrete mix, the ASTM numbers, pipe fittings, sizes, labels. Lays it out pretty clearly what you should be checking for materials as well. And for also in the quality assurance plan, it will lay out basically each practice. You have the manure stacking structure, what you need to be checking on that. Make sure it's in the right location. You want to do a couple cross sections when you complete your as-builts. That's where you need to be taking your concrete slips. And for each specific item of the design will be laid out in the quality assurance plan to check. So if there's ever a question of what you should be looking at, you just want to refer to the quality assurance plan. And then it's also good to have the designer sign the quality assurance plan. You want the inspector, the supervisor of the inspector, and a backup inspector. All those people need to know their roles and responsibilities before the project starts to take place. But and then we'll look at a farm here, 150 cow dairy operation over in Snyder County. That they have a lot of best management practices going on. But the first picture we're looking at, it's kind of what we see when we show up to a typical dairy farm. Push off the manure into the manure spreader, and the runoff from the manure spreader, when it's not parked there off the push off, is not contained. And when it rains, it's going to wash more manure down over the hillside. And there's a lot of problems going on here at this farm. Here's a view from up above. You can see the water's not really controlled. The waste isn't controlled. If the spreader's not there, it's going to be running elsewhere. And here's a view from up above looking down over the hillside. You can see what that manure is doing. It's just escaping down over the hillside, killing the grass, and getting into a drainage way on the lower side. There's another view from the lower side looking up. And this is at another location on the same farm. Here you can see we've got milk house water along with some manure leaving the farm, heading down to that same drainage way, which is pretty severely impaired. So what's first step to do, or what's one of the steps to do to catch that milk house water? We're going to catch that water, put it into a tank to where we can control its release. And then we're typically going to pump that to a manure storage. There's a large tank that we contain it. If we don't have a manure storage tank on that farm, we can dilute the water and we can put it out to a spray irrigation system or a manifold system to treat that water over a vegetated strip. But here you can see we installed a large manure tank with a conveyor system to transfer the manure from up above where the heavy use area is down to the tank. There's another view of the tank, everything collected inside. But this is the other section of the heavy use area. You can see it's pretty irregular shaped and be very difficult to control all the water coming off the pad and to build a roof over to keep water from running off the pad. So what we did, well, we're looking back at the construction site. So here we have the silt fence, first step to go in, then we strip the topsoil off, and then we're starting construction for that manure tank. You can see we've got a track loader down there shoving the material off. And this was a pretty wet construction site. You can see the water on site that we had to deal with there. So what we do when we have a wet site, a lot of times we'll over excavate and we'll install a geotextile, and then we'll add a stone to that geotextile to bring our footing pad or elevation back up to grade where we need to be with a strengthened soil base. In this geotextile here, you can see by the glossy look, this is a woven geotextile. Here you can see we're roller compacting this subbase in. And here all the subbase has been compacted. We added another layer of geotextile over that subbase. And then we installed the reinforcing steel along with the concrete blocks to act as chairs to hold that the steel up into the middle of the concrete. You can see we've got the form going around the outside there to contain the concrete. There's a better look at the concrete blocks being used as chairs. And here they're placing the concrete. They've got an aerial pump truck placing the concrete at the back of the picture here, and then you've got the guy screeding the concrete with a power screeder. And here we're performing a slump test. This is something we typically do on all of our liquid tanks. You got a cone on a slab and you scoop the concrete. Typically we do this every truck. We take a sample, a 5-gallon bucket of concrete from every concrete truck that arrives. And you can see the little metal scoop in the bucket. We'll scoop the concrete and we'll fill that cone a third of the way up. And then the metal rod that the fella has in his hand, we rod that concrete 25 times. And we do that 3 times till the cone is completely full, and then we strike off the top, and then we remove that concrete cone in 5 to 7 seconds. And then we measure the distance from the top of that cone to the top of the concrete. And that's what we would call our slump. And that's how we test the flowability of our concrete. We don't want it to be more than a 6-inch slump without using a super plasticizer. And typically we try to use a 5-inch slump without a super P. But when we're pumping tanks through an aerial pumper, we'll use a super P and we can go up to a 7.5-inch lift, which would be that distance measured from the top of the cone to the top of the concrete. And we can also take concrete test cylinder molds. So this would be taking a sample of that concrete, rodding it, installing it into this mold, and those would be kept in a controlled environment. And then if we have a problem with the tank, say some concrete spalling or the tank is developing cracks, we can come back and have these test cylinders broken and test the strength of the concrete so we can rule out whether it was a problem with the concrete coming from the plant, and then maybe we'd look at a concrete handling problem, the weather, different things like that. But this is how we test the concrete strength when we're actually pouring the manure tank. Here we're looking at the vinyl water stop. That's the material, the white material we're putting on the inside of the rebar. What that does, that provides a watertight seal. Half of that water stop is into the concrete floor, and the other half, when we pour the wall over top of that, would adhere to the top of that water stop, and that keeps the water and manure from following that floor slab right on through that joint of our wall. And here we're looking at reinforcing steel in the wall. This is what inspectors typically going to check. We've got number 4 bars on 6-inch centers, and the steel schedule varies between the tank sizes, but it's just a good example of what you need to inspect when you're inspecting a manure tank there. And here we have a transfer pipe that would carry the manure from the barn above into that manure storage tank. And you can see how much detail is needed in placing that reinforcing steel around the 24-inch manure pipe coming through. Here's just a good view of the entire work site going on. You can see they're placing the wall steel in this picture, and they've got their forms laid out for those walls. Here's a good picture of the aerial concrete pump truck. On the back of this truck that you can't see is where the concrete trucks discharge the concrete, and it's pumped up through that line and out into the forms. There's a better picture that you can see the concrete trucks discharging into the pump truck. And here you can see the guys using that aerial pump truck. They hang onto that hose and they work that concrete down into the manure tank, the wall forms there. Do that in a couple lifts. And in this picture here, you can see what's the finished product. And you can actually kind of see their lifts of concrete they put in. The lower half of the wall, it's a little slightly different color, and you can see the above that concrete, as you can kind of see the seam there where the two concrete pours mixed. Maybe a little more vibration, you wouldn't see that seam as well. But you can also see all the patches on the wall, and what that is they're patching the form ties. There's a little metal strip that connects the outside form to the inside form, and after they remove the forms, they snap those form ties off, and they need to go back and patch each one of those form ties. That's why you see all those patches on the wall. Here you can see the outside of that manure tank wall where the pipe protrudes through it. We need to get a lot of really good compaction above and under that pipe so we don't have any settling go on and then have a chance of breaking that pipe right where it meets the wall. Here we've got an excavator just is digging out for that transfer pipe up through there. It's a Cat 312. It's about a 30,000 pound machine. A lot of time in our inspection plans, we'll have different weight requirements for dozers or compaction equipment. So just going to try to give you an idea of what some of the equipment weighs that would be used on the typical job site. And here we're seeing a remote control sheep's foot roller. Jen had one of these in her pictures, but this is what we like to use when we're in deep excavations. You don't want to have a person down in that deep trench vibrating the ground, possibly loosening up the material above to come down and cause an injury. Here's the hopper bases. It's one of the transfer items we're taking the manure from the barn down to the manure storage. We have slopes that we can't exceed whenever we're transferring that manure, and we use these hoppers to help traverse those slopes. And here's a good example of that. So we have the manure coming in the top of that hopper. It would go down through the stacking, call that a chimney, and then through the lower pipe out to the manure tank. And here's a good example of that upper hopper is installed, the upper pipe is installed to the top of the chimney. And there's the hopper where the manure would actually go into. That'd be connecting to that upper pipe. And here we're roller compacting the ground in. We're going to have a concrete slab over top of this. We don't want any settling going on. So, and we're up out of the deep trench, so we can have a manually operated compactor there. It's a smooth wheel roller. This is called a jumping jack. This is what you'd use in close quarters for compaction. I normally don't want to go more than 6 inches of a lift at a time with these jumping jacks, but they work really well for getting compaction in tight areas. Just a typical backhoe you'd see on a construction site. It's about a 20,000 pound machine, rubber tires, single axle dump truck, 8 to 10 tons, basically a municipal dump truck. And here's a tandem axle dump truck. These trucks would typically carry about 17, 18 tons at a time. And a triaxle dump truck, 20, 22 tons. That's about the maximum you can haul on Pennsylvania roads. Off-road dump truck, we don't typically see these, but those trucks can carry more than 100 tons at a time. The dozer, this is a D4G dozer, about 20,000 pounds, very typical of what you'd see on our construction sites. It's a smaller dozer. And a track loader. These are kind of becoming eliminated with the use of rubber track front end loaders, but this machine here probably weighs about 30,000 pounds. A rubber tired wheel loader. This is what we typically see on our larger dairy farms. They're handling some sand here. And a good rule of thumb for these type of loaders, you want to when you're doing an I&E or a visit, you want to find out how much sand they're using per day. You can find out the scoop size. This machine can handle about 8,000 to 10,000 pounds in one scoop. So the farmer says, well, it takes me 1 scoop of sand bedding per day. That helps with your calculations later on when you're sizing the manure storage. And here we've got a typical skid loader used on a farming operation. A typical scoop with this machine would probably about 2,000 pounds, and the machine weighs 6,000 to 7,000 pounds. Road grader, we don't see much on our sites, but they're used very often with the townships and dirt and gravel road programs for regrading roads. Here we're just looking at a smooth drum roller compacting a gravel heavy use area. Scraper pan, we don't use these too often. Sometimes on the WRE wetland reclamation jobs or enhancement jobs, we'll use a pan, but not too often. They're typically on much larger Western construction sites. Some directional drilling. This is kind of the way of the future for a lot of excavation going on as things get built up. People don't want their yards excavated, or you need to go under roads. These machines excavate a trench, you can bore underneath the road and then pull your utility pipe back through it. This is the locator that drilling companies use. They can determine the depth and the speed at which that head is going and which direction it's going. And here you can see that boring operations. They've opened a pit on the other side, they bore into the hole, and then they will pull that pipeline back through the hole that they just bored. And here there's cutting some concrete for some control joints. This is just a hand-operated, gas-powered concrete saw. And here's a walk-behind saw, which what we typically see on our large heavy use areas or concrete jobs. It's much easier to use, and you can get a much straighter line for cutting our control joints. Vibratory plate compactor. These compactors only weigh a few hundred pounds, and we don't want to install lifts more than 2 to 3 inches when we're compacting with these compactors. They just do small areas. Jackhammer. Try not to get these on our sites, but just because they're very labor intensive and can be dangerous to use. This is the world's largest excavator, I guess. At least I believe this is over in Germany. And then just for a reference on size, the top of that picture, you can see they accidentally dug up a bulldozer that was on site. Grooved float, this is on our heavy use areas. We oftentimes ask the landowner if they'd like to have grooving, and they can decide whether they want the grooving or not and what type. But this is what we typically see the grooves placed with. It's just a bowl float with the grooving edges installed onto it. And as they finish the concrete, they can drag that across the concrete and give it a nice groove surface to provide the animals a little bit of traction. And here you can see the grooved concrete, and the contractors installing the curing compound on this recently poured concrete floor. And here's just some good before and after pictures. You can see a barnyard here, manure's stacked up. The animals actually have access to the same area. No way to control runoff from this site. So what was installed was a concrete slab. We have a push off. There's a filter box below that to collect the runoff water and take it to a filter area. But manure can be scraped up and cleaned as needed. Another barnyard. And another heavy use area with a screen box conveying the water to a filter area below. This is a very large barnyard. Got some roof water controls controlling water off the barns, but the water off this lot is obviously uncontrolled. No good way to collect manure. And so what was done was basically it was concreted, another filter box to collect the roof water, and then the landowner can scrape up the manure and haul that out as needed. Here's the WRP project where some flood events threatening a house and some structures here. So what NRCS can do through the Emergency Watershed Protection Program can go in and provide stream bank stabilization, whether that's retaining walls, riprap, different stream bank practices. It's a good before and after shot there. Here's some of the riprap being placed along an eroding stream bank. It's an after shot. And this is a WRP site. We can go into farmlands through the WRP enhancement program and take farmlands that had previously been drained, and we can turn them back into wetland wildlife habitat. Here's just some best management practices we're going to look at. Looked at or talked about some contour strip cropping. Here's some good pictures of some contour strips on the field. Running those strips are being placed or being grown on the contour. Here's a cropland terrace that we can farm through. Another way to manage water. These terraces have a very shallow slope, can manage the water, and then we'd take that to a grassed waterway. We've got a diversion that's on the contour. These typically run 1 to 2% around the contour and would also discharge into a grassed waterway. And here's the grassed waterway that traverses down over the slope. Terraces can outlet into these grassed waterways. The diversions outlet in these grassed waterways. We do hit some maximum slopes where we would then transfer into a rock-lined waterway. And here we have a surface inlet. We put these surface inlets in to take the concentrated flow, whether maybe we have a spring seep or a road culvert that discharges a continuous amount of water. And what we want to do with these surface inlets is we want to take that concentrated flow that would otherwise keep the grass waterway saturated and cause erosion in our grass waterway. We want to pipe that concentrated flow down to the stabilized outlet. And the overflow that the surface inlet can't handle would then flow into a grassed waterway. And here's a rock-lined waterway. So we'd had the grass-lined waterway coming down over the hill. At the end, it gets too steep to maintain a grass-lined waterway, so we have a rock-lined waterway. And you can see on the right of that rock-lined waterways where we have the outlet pipes discharging. Wetland restoration project here. And then here's where we're looking at the screen box where we had the heavy use area lots. We put these screens in to catch the solids so that they do not go into our filter systems and our pipes and plug those up. Then screens can be pulled and the solids can be cleaned out with a shovel or skid loader. And here's where that water from the screen box goes to. This one's going down to a manifold pipe. And that's why we have the screens in there, to try to keep those holes from being plugged that you need to clean later. But these discharge onto a permanently grass vegetative strip. It can be mowed during dry seasons or grazed off. But we rely on the grass to uptake the nutrients off that heavy use area lot. Good shot of a roofed waste stacking facility with an open barnyard. We have to do that open barnyard whenever we have good soils in the vicinity of our project. We have to use the least cost alternative. So if there's good soils, it's cheaper generally to catch the water off the lot and put it to a vegetated treatment area than build a roof over the entire project. Here's another view of, got the lot water being piped down to that long grass. It's going to be a grass treatment area, but that pipe there is what will be discharging the effluent from the heavy use area above. And you can see the roof over the manure stacking area. And here we have a carcass composting facility. We don't do a lot of those in the West, but practice NRCS does do compost dead birds or animals from the farm. Just checking the temperature. It's a compost thermometer there. You need to keep the compost at a particular temperature to keep the materials composting. Spring development, do a lot of these. We're catching the water up on the hillside, pipe it down to a concrete trough or tank, give the animals access to that. It's a good way to get the animals their water source without having to be mudding up the area right where the water is coming out of the ground. Typical well drilling rig, drilling a water well where there's no springs or on top of the hill, so they can drill down, catch the water, maybe put in a solar powered pump to transfer the water to a grazing system. Here's a good look at the drill bit, carbide tip drill bit used by the water drilling rig. And here's a look at the finished product. It's a wellhead, got our water line coming out of the side of that. They need to finish the concrete collar and finish around the water well there. But there's some good information to be had when you pull the cap off the water well. And we need to know this information for when we're completing our water system design. So when you pull the cap off, it should always tell you the well depth, the casing depth, and that is just where they're getting through. Sometimes they're in strip cut ground. You need a casing through the strip cut ground to eliminate iron, water, or maybe it's uncompacted or it's not well compacted material that would cave in your well. So you're casing through that. And then you want your gallon per minute rating there. You can see this well has a 50 gallon per minute rating. Here's pressure tanks or bladder tanks, because water is virtually incompressible. You use a bladder tank. Half that tank is filled with air with a rubber bladder in it. And as the water pressure builds up, it's pushing on the bladder to maintain your water level. And then as you use water, that tank will drain back out. The air is pushing back on it to keep your pump from kicking on and off every time you open a water valve. Here we've got a frost-free watering trough. The animals would go up, push on the blue ball, and beneath that is the water where the animals can get a drink. Another look at a frost-free water trough. You can see the float in the trough from the pressurized system. You can also look down in a heat well. These frost-free troughs can be operated a couple ways. It can either be run off electricity with a heating element, or you can put a heat well. And what a heat well is they dig a deep hole in the ground, typically 10, 12 feet deep, put a fairly large diameter pipe, 10 to 12 inches in diameter, and you run your water lines in through the side of that pipe up the center. And what that does is it allows the heat from the ground to continually circulate around that water line to keep it from freezing. Just a solar powered watering system. Installed several of these in remote locations where you don't have access to electricity. Your typical stream crossing here. Got some hog slats to provide stable crossing for the animals. And here's one of the roof stacking areas where there's stacking litter and manure to keep the rain and weather off of it, keep the waste dry. Installation of gutters. It's a long run of 6-inch gutter here. One downspout couldn't handle it, so they installed 2 downspouts to take the water to the 4-inch pipe. And here's a hydraulic ram manure pump. On the top, on the right-hand side is the hopper where the manure would be pushed into. And then the manure goes down in. There's round cylinder part in the center of that picture. Basically acts as a vacuum. It sucks the manure out of the hopper. A gate closes between the hopper and that round cylinder. The gate between the round cylinder and the manure storage or the pipeline out opens, and then that cylinder pushes the manure down and then out to the discharge pipe to the manure storage. Here's a mechanical ram pump. Operates very similar. It's just instead of being vertical, it's operating horizontally. Would suck the manure in from the hopper and push it down the tubing to the manure storage. Here's a water level control box and blind inlet. It's hard to really see what you're looking at, but on the left-hand side, you're looking at the water level control box. There's a pipe that's installed in that gravel, the pile of gravel, and they call it a blind inlet because you can't exactly see the inlet of the pipe. So that's keeping a lot of debris, fish, turtles from plugging the inlet of that pipe. The water travels over to that box, and then there's different baffles in that water level control box. You can pull them out, add more, and that the water has to go up, travel over the baffles inside the box and back out. That's how we control all the water levels inside our wetland projects. Agrochemical handling facility. We build these to allow the farmers to handle their chemicals in a controlled environment. If they spill something, we can contain it within the floor area of this building. And we also install eye wash stations. So if there's an accident, they can safely get cleaned up. We always got to advertise on the side of the door what is inside the building so that people know it's not anybody's welcome into that facility because there's chemicals in it. Here's a warm room inside a facility. Could be a heated room to keep all the chemicals that can't be allowed to freeze. Here's a project when they're pouring the concrete inside that ag chemical handling facility there. Insulated blankets. We try not to use these on our products very often because we don't want to pour concrete when it's cold, and our requirements are pretty labor intensive and expensive to pour concrete in the wintertime. But We require an R value, typically an R8, depending on the temperature, to keep that concrete warm. We want to keep our concrete above 50 degrees. Here's a lined manure storage pond. We don't do many of these anymore just because they take up so much space. But here's a flexible line manure storage pond, lagoon. PTO powered manure pump, unloading the manure from one of our concrete manure tanks. And here's a mechanical pump unloading the manure from a slurry store tank, unloading out of the bottom. Typical liquid manure spreaders. These liquid spreaders here have injectors on the back to where they dig a little furrow, basically burying the manure as they go, helps with odors and incorporating the nutrients. Some jute netting installed on a freshly installed waterway. Some gabion baskets controlling the outlet of a grass-lined waterway where it discharges into a township road. We install these gabion baskets to keep the water from cutting back up our waterway, helps spread it out and keeps an even flow of the even discharge of the waterway. Retaining wall blocks are concrete waste blocks, typically used around a barnyard. Here we've got a Zimmerman push-off guard sitting on top of those where they're pushing the manure off and would be into the manure spreader. Using the same blocks, same type of blocks as a retaining wall. Here we're installing trusses on one of our facilities there. You can see we've got a crane hanging the trusses. And one of the important things to check whenever you're inspecting a truss, this is the truss shop drawing. There's a lot of information on here. At the top, you can see the web members that are circled there. That's our continuous lateral bracing that's specified by the truss designer. And tell you what the top chord bracing is. They have the top chord purlins on 2-foot centers. On the bottom chord, we've got bottom chord purlins, rat runs need to be installed at 6-foot centers. And then you can see on the webs, they're telling you 2 rows of web bracing, joint 5 to 14 and 7 to 14. So that center web, we've got 2 continuous laterals installed on that. More information and more things you need to be looking at a construction site, just looking at the details of the nail cartons. I've got 3.5-inch hot dip galvanized 16-penny nails. Looking at another box of hot dip galvanized spiral nails. And here we're looking at typical inspection grade on a lumber. So in our projects, we have different types of lumber that need to be used. This material here, you can see the SPF. It's a spruce pine fir, kiln dried in the NLGA, the National Lumber Grading Association. This has been graded as a number 2 board. We either use southern yellow pine or spruce pine for lumber. All of our structural material needs to be southern yellow pine. Here, this is a post we're looking at here. That's a southern yellow pine. It's a Southern Pine Inspection Bureau. It's kiln dried to 19% moisture. 870, that would be the plant the lumber is manufactured. And the 2400F, that's mechanically stress rated lumber. It's a 2.0 E value. Looking at a typical water line, this is what you want to look for. We're checking ASTM, our ASTM D2239. That's what we always rely on. And you can see the 200 PSI rating on this pipeline. Normally use a minimum of 160 PSI rated pipeline. When you're looking at a pump, you want to look at the horsepower. You can check the model number and refer to the pump manufacturer charts to make sure it meets our needs that was specified in the design. And that's all I've got, Tim.
All right. Thank you, Justin. And I'm getting some feedback. I'm not sure if everybody's getting that. But so there were 2 comments in the chat, and the first one came from James Palmer in Somerset, and he said he used number 9 bar on 6-inch centers in his driveway when he poured it years ago. I would say it would be an understatement to say you have a beefy driveway. But your brother-in-law drives a truck and he thought he couldn't drive it on my driveway with his Peterbilt. I'm not sure. I'm not going to comment on that, but that's a beefy driveway for sure. The next Justin, the next is a question, and is the well information found on the well cap found on most well caps, even for residential homes?
Yes. Yep. Generally, that's a requirement within Pennsylvania. You want to have all the information on the well cap.
Very good. Any other questions for Justin? Well, we're going to slide back over to Jen Harold then. So thanks a lot, Justin. We appreciate that. And Jen, at this point, we'll take it back over to you.
Okay. Can you?
Yeah, we see it.
Okay. All right. So working with landowners. Over the years, working with people in general, you have to learn to deal with different people, and it's definitely with farmers. That's definitely the case. Some are easier to work with, and some you have to earn their trust and move forward. So the one thing is you want to make a good impression. If you have an appointment, make sure you get there on time. If you're going to be running behind, let them know ahead of time. Now, this was a slide made before COVID, try to travel together, but now it seems like you have a lot of vehicles out there with everybody driving out separately. Don't talk against other farmers. If you're, like I said, if you're running late, give them a call. And then you can't overwhelm them, especially with like an inventory and evaluation on I&E, the engineering trip report trip. Sometimes if you have too many people, it is overwhelming. Sometimes you can see those farmers' heads spinning once we give them a bunch of ideas. And don't goof off. I've also been out in the field where somebody's been off to the side, not really paying attention. And if you're out there, you should be involved with the conversation. Also, especially dairy farms, you make sure you park out of the way, away from the milk house. So if during the visit the milk hauler comes, you don't have to move. And then the other thing is, say you stop for lunch after the visit, it's probably not the best idea to stop at the local bar and have some beer. So the big thing is make sure you listen. Don't rush through the visit. A lot of times my first visit to the farm is the I&E. I usually like to know what kind of project they want to do my homework. If it's something I'm not familiar with, I read the standards and know what I need to fall within for a design. Take notes, take a lot of pictures. A lot of times, I refer to the pictures a lot through writing your I&E or even the design phase. And I always try to compliment them on the things they're doing well. They like that. So, beware of the trending issues. With COVID in the last year, I had to do some I&Es by the field office sending me pictures and then talking to the landowner on the phone. So it's definitely changed in the last year how things have been a little out of the ordinary, but communication and we seem to overcome that with a lot of these virtual things. Also, whenever you are working with a landowner, the gas industry is probably the most concentrated areas in Washington County. And there's a lot of things to work around. These gas lines, the drill pads have taken a lot of good quality crop ground, and they've made it difficult for the farmers to farm and try to plan things just because you're limited by right-of-ways you have to work around. Here's a drill pad. I had done an I&E on this farm, and this would have been a perfect spot for a nice roofed heavy use area or a heavy use area stacking area combo. There we go. So this is an aerial photo of that same farm. You can see the drill pad. It's taking up a large area. There's a pipeline with a right-of-way, and then they had a huge road into the drill pad, which they just took acres and acres. And then we're stuck with these limitations and being able to work with them. But communicating with a farmer and knowing what he can and can't do is good to have in the game plan. So always remember that the landowner owns the land. Always let them know we're coming. It's kind of funny that watch for Kate, the guard dog. That's one thing you always have to kind of be careful of dogs. I've never been bitten, but there are some scary ones. I might just sit in the car and wait for somebody to come out. Over the years, I've learned to work with a variation of farmers. This is a CSA that was in an urban area where they have a smaller footprint, but they want to improve in irrigation. So, we work with like the urban farmers. This is another irrigation project, more out in the countryside. So we work with, diverse folks. High tunnels are a pretty hot commodity. It's not really an engineering practice, but, those folks that are growing crops like this, I like to be able to relate to farmers, and my mom used to have a certified organic greenhouse. So I always just enjoy, I was just at a farm the other day that the landowner is diverse. He has a dairy farm, beef cattle, and he has greenhouses. And it was just so nice to be in a nice warm greenhouse on a cold day. And, I talked about that a little bit to relate with him. Some landowners are interested in different things, that are new practices that we hadn't done for a long time. But, farming with pollinators, the field people, this is a good way to sell, buffers with wildflowers. It's going to increase their production of adjacent crop fields with all the extra pollination. So there's farmers or, people just interested in things like that. Not a necessary in ag waste or something like that, but and the golden wing warblers, that's another newer program where there's been a lot of interest, where the numbers are falling, and some reduction, some management in the forest can help bring these little critters back, and that's been a great program. So here's just a Matt, he was the forester here in Somerset, and he had given me some of these pictures of different practices. So this was a young forest, and providing habitat for a variety of wildlife, including the golden wing warbler. So we work with a variety of folks. Some of the Amish work with us, and sometimes they don't take money, but they like the help, the CTA assistance. They want to make improvements. Communication may be a little different. They may just have a phone booth at the end of the lane where they would call you, or you could leave a message. And then I worked with some Amish contractors where they both had cell phones. I guess they're business related, but you see a variation of how strict the rules were. But the young person in the business, a lot of times the dad makes the decision. So it's just different, but they're willing to work and make an environmental improvement. And just knowing the communication may be a little different, but they've become a little bit more advanced in a business world with maybe getting emails and things like that. So, working with the landowners, you want to promote, if you go to the site, you say, oh, this would be a great riparian buffer, and talk about CRP, planting trees, the benefits of, having the water filtered through the trees before it gets to the stream, the temperature of the water improved, and things like that. We work with a lot of grazers. It seems like farming's tough, and the bottom line is how much money can you make, and if you have the cattle doing the work and harvesting, you can make a little more money sometimes. So we work with these landowners about working with the grazing specialists and fencing, the water system layout, pipelines, springs. Here's a picture of an INE. Went to a little beef operation, and he was really proud of this little pad. He had a concrete pad outside the barn. He built this waste concrete block wall. He could push against, trying to load a spreader. And I complimented him. He was trying to do make improvements, and said, "This is great, but let's see what we can add a little bit onto this." We planned a roofed heavy use area and stacking area. And this pad was going to just be used for equipment, not for the cattle anymore. There would not be any runoff controls or runoff because the cattle were off this area. So the big thing is talking to farmers and giving them eye contact, stay focused, and tailor each visit and advice to the individual. I find it very handy to show practices of installed, or pictures of installed practices. We have when Tim was here, we made I forget what it's called, portfolio for ag practices, which I have one printed off when I go out to the farms. And you're trying to explain something to the farmer, even to the field office if they're not familiar with it, and show them pictures of what we've done is very, very helpful. Family pets, the farmers love their animals. That's what makes them the money. So, they just love them, and I can feel the same way as, like I said, as the cattle have been tamed by my daughter. You can scratch them. I can get the curry comb and brush out the one cow now, and last year we couldn't. So they're just like another part of the family. Farmers do research before making decisions. I don't know if anybody knows JB, my husband, the grazing specialist, but he's always looking stuff up. My son, he's got the itch for farming as well. You get the Fastline, it's like a sales magazine for equipment, I don't know, in a large area, but they're always looking at different equipment. How much does it cost? What would be better? So they do their homework. And you need to provide good information so they can make good conservation decisions by what we recommend. And you don't tell a farmer to make a change, they elect to do it. You can give them guidance, show them examples, but you don't tell them what to do, you give them guidance. So say you show up at a farm and they haven't quite finished up milking, just say, "Hey, I'll just take a look around, I'll be outside, let me know when you're ready." This has happened a lot, especially on a cold day. A good place to lay out the drawings and talk where it's a little bit warmer is the milk house. It's quite handy on a brisk day. So what makes people implement change? Providing good information. They have to be committed. Getting good advice, have them talk to other farmers, say if there's been a similar structure built somewhere, have them visit it, talk to the landowner there to see what they like or didn't like. The support to help them through the process of planning and designing and implementation, and giving that technical assistance that we're so great at for them to build these things. And the financial assistance, NRCS, there's Growing Greener, there's a lot of programs out there. REAP's been very popular with helping to pay some of these conservation practices. So you have this beautiful pond, the prized pristine pond, and you get the call because they're like, "Well, we've got these pigs here. You see below the road is the little wooden shed is the pig pen, and they've got quite a mess. Hogs are just hogs, making this mess here. And obviously you're going to have runoff towards your pristine pond. So they're like, we want to make this better. We want to make sure this water's clean. And you can't see the farmstead on a drive-by. You've got to be invited and stop by and see everything, how this whole system works. Can't see it all from the road. I'm not sure if any of you have calibrated a manure spreader. I've done that back when I was the certified nutrient management planner. But you lay out the plastic at a certain size, have the tractor and the farmer drive by at their typical speed and RPMs, and then you weigh how much the plastic weighs to determine the weight, the pounds per acre of manure spread. So something went wrong here. Apparently the plastic blew off the ground, but it's kind of a funny little picture. So yeah, you have an I&E scheduled. You get there and you discover this. Not such a great day for a visit. They may not be in the mood to chat about conservation farming, but apparently it was a little too wet to get out in the field that day. This has happened to me multiple times. It's summer. We finally have some dry weather. You have an appointment, you get there, and they either have no time for you or 10 minutes. And that's when the sun is shining. It's time to make hay, put the crops in. And that's a difficult thing when they don't really appreciate your time, but it happens. Some of them tell us and cancel, but sometimes you show up and they had totally forgot about us. So the way Grandpa used to do things, changing that mindset is a tough sell. A lot of these conservation planners have a hard job to sell, say the no-till, like the no-till, minimum till. They've done it the same way for all these years, and it takes someone to really show a good example and maybe start with a small area of no-till and work their way up, but that is a tough sell. And when you do have farm visits, make sure you include the younger kids. You know, they are the future decision makers. A lot of times the farms, they're hoping that the kids are going to take over the farm after the parents want to retire. So always include them in the conversation and help them. They can help make decisions as well. Be able to recognize issues. So this barnyard looks pretty good to me from, just from the side here, but over the years, they decided to cut, because the water wasn't going anywhere, they cut the curb out and it was directly discharged to the stream. So that's a resource concern we would have to talk about and how we could fix it. So be able to recognize issues such as that and how to remedy them. This is a photo of a road culvert dumping basically into a stream, which turns into it's in karst topography, into a sinkhole, and it just disappears. The water's gone. There was severe erosion. The cattle are all around this sinkhole. The wastewater from the milk house was dumped into there, and we're excited that they moved into an equip contract and will eliminate the manure runoff and the wastewater from entering into the sinkhole. It was pretty bad. So they were going to do a new barnyard, a manure storage, and improve pasture, and definitely a setback from the sinkhole, which you see on the right. Biosecurity, be familiar with that. All of our government vehicles, we have bio-booties or we have wash stations in our vehicles. If you're going to visit, say, a poultry farm, which they don't usually let you in, but limit a visit, one per day. Hog facilities, they don't usually let you in there. I did get to peek into one last year, but don't walk. Say if you're walking around a farm, don't walk where they feed. the cattle silage after you've walked through the manure. Just stay off the area where the feed is. You don't want to cross-contaminate the manure into the feed. So some farms have biosecurity measures signs up. Good thing is to ask the farmer what his policy is. Like I said, hog and poultry facilities are usually more particular than a dairy farm or a beef operation, and avoid the multiple visits on those. And watch where you drive and walk. You don't want to carry manure into the feed and drive through manure and then drive down to the next farm. And it's good to wear those bio booties. If you have a longer visit, you end up tearing, getting little holes in the bottoms, and sometimes falling off. But it works well if you take rubber boots, have a jug of water in the vehicle, some Dawn and some Lysol, and clean before and after you leave. Farm safety as an engineer is one of my main concerns. Kind of scares me sometimes when you go to a farm and see some issues. Children's safety is one of my top concerns, of course. Worker and animal safety is another one. Manure storages, sometimes we see older ones that we were not involved with and the fence is gone or there was never fence. I do bring those things up. If we're going to put money towards projects, we need to bring the current safety measures up to the current specs. Manure gases and gypsum bedding were, years ago, once we discovered the combination where the gases were causing deaths as you agitated a manure storage. Now we have better signs for that. Here's the push off into a manure storage. This is a kind of a dugout pond. I see some safety issues here where you could easily climb up the wooden fence, jump in the pond if you really wanted to. This would be a more current push off, but there are some issues still. If you were to stand on the push off curbing, you could actually jump right into the storage. So I don't have the picture there, but we would usually extend fence out from the each post of the push off guard, either with some fence straight out where you can't step over, or a triangular piece that'll fill in this gap here where they can't step over the wall. One of the things before I certify a project, I want a lock on the gate, and they need to keep it closed. In the operation and maintenance plans, that's the one thing is close the push-off guards, keep the lock on the gate. We don't want kids getting in there. Another thing, when I'm going to certify a project for completion, I look at this is a manure pump and a underground reception pit, and I see some bigger openings here of concern. They should probably put some steel plating around these openings to make it less than 4 inches. Here we have another reception pit in the ground. Here's the manure pump. Here's the gutter cleaner, dumps into an opening, falls into the storage here. And here are the manure signs, and this is the pump housing. So there's potential for manure gases to build up there as well. But we've got the signage and safety protocol in place. Whoops. Okay, so before and after pictures. This is an Aspen stand before management. Whoops. And this is after management to control the brush. This is a post harvest on an aspen cut after one growing season. So you can see that they selectively cut, and then the ash are starting to grow. This is a photo of before we came in during an I&E. They had a gutter cleaner dropped into like a little stacking area. Manure pile everywhere. If there's any liquids, they're going to run off. They decided to do a liquid storage. They would collect the wastewater from the parlor, have the manure all self-contained, and there's a large barnyard as well. So there'd be a good bit of water collected off of the concrete lot and the wastewater. Here's a nice animal trail out to pasture. So here's a typical site we would see: beef cattle feeding outside. You see some ponding water here. They have access to multiple acres. Here, this isn't quite finished, but the feed would be placed on this concrete pad. This is a slotted curb where this is going to be maintained in grass vegetation. The cattle will not be on there. They'll be fed on this pad, and the manure-laden runoff will go through the slot and go through the filter area. Here's another site. They have, 3 different areas where they're feeding hay outside. No runoff controls. They'll probably collect the manure and pile it, and maybe spread it before the next winter season. But we came in, and here's a open lot. I don't know where the basin is, but we would have a basin where you would collect the runoff, or a slotted curb on the lower side, where you could collect the manure and stack it over in the corner, and use those nutrients whenever you're going to be planting crops or putting on hay to get it to grow a little better. Another beef operation where you have several acres disturbed, manure-laden runoff at its finest, and close proximity to the stream. We came in, did a large roofed heavy use area and stacking area, and a diversion was built above to divert the 25-year storm, and eliminated any brown area. And that's quite an improvement from several acres to this small, confining them to this small area. Here's another, I think I showed you the push-off guard over here. Well, they did some strip mining adjacent to this farm. And of course, while the guys were doing that work, the farmer's like, hey, can you dig me a hole? So this is just a dugout hole. There's a lot of, I'm sure it leaked, a lot of rock was exposed. I know when we took this apart or closed this, but no safety fence around here. If you didn't really know, you could just walk across and then just sink, and you'd have some emergency situation where we have to recover somebody from the pond. This is the same site where we put a Zimmerman type guard for the heifer barn, and then for the cows, they were down at this lower barn. We pumped the manure into the storage. Another site where this is a heifer raising operation. He has several hundred dairy heifers, many acres disturbed. It was overwhelming to know how much manure-laden runoff and sediment loss was from this farm. We came in and built. This is, I think, one of the 2 or 3 heavy use areas. Since then, he's quite a progressive farmer. He built some barns. I think he put a separator in. He keeps on moving ahead. So whoever he's contracting with, he's doing well. I know the dairy industry's a struggle, but he's been progressive still. This is a barnyard up above. This is where the water would all go, like a discharge here, and then just overland flow. And then, of course, the cattle had access, and there's really no filter area for the runoff water. So this is the same site. You can see this is the wall of the stacking, or the barnyard. Collected that water, and then have a vegetated filter area. The cattle are off of that, and then we can have the nutrients absorbed, uptake by the grassed area here. Example of an eroding pond embankment here. Looks like barnyard runoff. I'm not sure what's upstream or downstream here, but came back in, to protect this embankment, did riprap outlet for the waterway, and repaired this embankment. We see this a lot for like the bigger cattle or bigger animals, just a pad that they would put the dead carcass, cover it with compost or manure. We can go in and improve it. These bins are more for maybe poultry or smaller pigs, things like that. You can see some clearly eroded soil here, concentrated flow. Farmers like, yeah, I'm starting to get a gully in here. You get into the farm there and tell them, yeah, we can build a waterway. You're going to have to give up some of your cropping field and maintain that, mow it, maintain it, but it's going to improve your situation. This is some more WRP or EWP, Emergency Watershed Protection, where the large storm event, this house here needs protected. The previous structure here obviously has been undermined and then collapsed during the flood event. Came back in. They used another approach, looks like stacked rock and some really large riprap here to improve the situation and protect the house. This is a permanent easement for WRP. The muskrats have went nuts in here. Just the pond was, the banquet was leaking. Came back and repaired the holes, rebuilt the embankment. There's some erosion control methods here. It looks like some sort of a blanket to improve that and hold, so it can hold water again. It's very rewarding to see conservation changes, and I wish you the best in your career, and thanks for the opportunity to talking with you. Best of luck to all of you. Tim, that's all I have.
Great. Thank you, Jen. I appreciate that. That's excellent. And, Jen had great things to say. And I really do think that one of the best skills we can develop is, learning to work well with a variety of landowners, a diverse clientele that we deal with. And like Jen mentioned, the urban farms, there's a big initiative right now to support urban ag. So more of that's going to be coming, in my opinion. We do have a question or a quiz to post, so I'm going to share my screen quickly here, and if anyone has any questions for Jen, you can think of those in the meantime. Okay, I'm going to copy the link to the chats. All right, you should all be receiving that link. Go ahead and respond. What the question is: when working with landowners and farmers, it is important too, and there are a couple options there, so go ahead and pick the one that's appropriate. And we are getting lots of responses, and everyone's on the same page for all of the above. Those are all correct things to do when working with landowners and farmers. Make a good first impression, be on time, and don't talk against them. So, and really, those things apply, I think, to working with anybody. And so good response there. I appreciate that. Well, big thanks to Jen and Justin and Mark. Oh, here's a question. Does Jen have any tips for working with farmers who like to point out how the neighbors' practices are worse than theirs?
Well, that's kind of funny because I did an I&E a week or so ago, and of course they're like, well, the neighbor down the road. So I don't talk against them, but it would be like, well, we could, maybe they could do this or that, but I try to do it in a nice way, but not like be negative. I don't know. That's the best I can do. But
yeah, I think that's good advice, Jen. It's there's not always a great answer for those tough situations we're in, but being positive and I think that's good advice from Jen. Okay, so that wraps up all of our presentations for the week, believe it or not. I jotted down a couple of notes as closing comments, so we'll talk about that quickly here, but we covered a lot of information this week. We talked about planning and soils and pastures and agronomy, wildlife, wetlands, engineering. I think that's the main topics we hit, but you also connected with a lot of staff and presenters from across the state. And I think that those people can be a great support to you in the future. So I hope that you reach out to them, contact them if questions come up or if issues come up, don't hesitate to reach out to those resources that you have developed this week. And then, Pennsylvania, in my opinion, is a really unique state for agriculture. We have a ton of small farms. A lot of other states have some bigger farms, but Pennsylvania just has a high number and a lot of small farms. And I think there's a variety of reasons for that, but we also have a unique topography. We have where it just suits smaller farms really well, I think. So that's something that we deal with, and that presents extra challenges, but I think it's also an opportunity to work with a lot more people. And then Pennsylvania, another thing with us is that we are the second in the nation when it comes to miles of streams. And that presents unique challenges to addressing resource concerns in the work we do. It's just a water quality challenge, and there's opportunity for environmental issues because of all the streams we have, and therefore there's lots of opportunity to make improvements. So dealing with our small operations and the streams just makes things interesting, a lot of fun in Pennsylvania. And then also in Pennsylvania, another thing that I think we do a really good job of, and maybe some other states, you wouldn't see this quite as well, is the partnerships we have. We have the Conservation Partnership in Pennsylvania, and that's a group that provides leadership and promotes conservation and natural resources. And that includes the State Conservation Commission, the PA Association of Conservation Districts, the PA Department of Agriculture, and NRCS. And I think that's really unique that we are different agencies and different groups, but we all have similar goals in supporting ag, addressing resource concerns, and conserving natural resources. And all of us on this call today and through this week play a part in that. And I think that's a really unique thing where we work together closely to accomplish the same things. And then we all bring different skill sets to the table. And I would encourage you to not only reach out to the instructors that you've met and worked with this week, but that you'd also work with each other. And I know it's hard being in a virtual setting. It's not easy to get to know each other, but a lot of you will be joining us for an in-person session later this year. And there's more good opportunities to do some good networking. Now, training in general isn't easy. It can be tough for both the presenters and for you. I know it's a big time commitment, and we appreciate that. And virtual trainings in general can be tough. And so if there was feedback that you have, or things that worked or didn't work, or things you liked or didn't like, let me know. I hope that next year we'll be back to in-person boot camps 100%, and that we won't have to do our virtual splitting things up like we are this year. But virtual trainings, I think in some ways, are going to be here to stay in a lot of different areas. So if there are things that we can do better on, let us know, or things that we did well on, give us some good feedback too. And then I think Carl Brown mentioned this in his opening comments, but just a reminder that the people that presented this week, we are professional conservationists, and we are not professional teachers. We do conservation for our jobs, and the teaching part is a small part of our roles. So if a presenter did a good job or something that you really liked, let them know. We don't get a lot of good feedback always. So, and if you don't have their contact, feel free to provide that to me, and I can pass that along to the presenters. Also, regarding boot camps in general, these courses, we had this virtual session this week. We're going to follow that up with in-person for many of you. It's a great overview, but that's what it is. It's really just an overview of a lot of different areas. And I think that it may highlight some different topics that maybe you don't have a real good, strong background in. And so I think that leads to the need for more training. And there are formal trainings from time to time that come up, but I really think and I really believe that some of the biggest bang for our buck for training comes from on-the-job training. You know, working with seasoned employees that are in your office or in a partner's office nearby. So spend time going out with some of those experienced people, bend their ear, ask them questions. And if there's a specific area that you are maybe a little bit lighter on, you know, ask for some help and ask for them to spend some time with you to pass that knowledge base on to you. And I know NRCS employees, we have IDPs, training plans, and you know, that's a good thing to keep track of. You know, what are areas that you would like more training in? What are areas you need training in? Document that and make sure that your supervisors are aware and that you're following through and getting the training that you need. And then one last thing to conclude on the training here is I'm going to steal a quote from one of our old state engineers. He used to conclude the boot camp meetings, and he used to use a quote from Thomas Jefferson, who said, "Far and away, the best prize that life offers is the chance to work hard at work worth doing." And I really think that's a good quote. And I really believe that conservation of our natural resources and the work we're doing, the work we talked about this week, that is work that is worth doing. And I hope you feel the same. I think that all of us are in positions that are just great positions to be in and very rewarding. And I hope you feel the same. And with that, I will conclude our meeting, and I will look forward to seeing many of you later this year, and then many of you as well for Boot Camp 2. So thank you very much for the good participation, and enjoy your afternoon and your rest of your week. Thank you.